now we come to the second lecture, overall the seventh lecture, second lecture of Unit 2. Having seen the transmission box, that is the gearbox, let us see the various selector mechanisms for selecting the gear which you want for your vehicle. There are many mechanisms used for selecting the desired gear and sliding it to engage the corresponding gear on the lay shaft. There are broadly two categories. The working is almost the same except for the positioning. The first is the gear shift lever is mounted on the steering column. Gear shift lever is mounted, or this is the steering column, mounted on the steering column, and secondly on top of the transmission case, that is the gearbox. However, both types are similar and only external linkage is different. Now let us see the parts. This is the steering column. This is the mechanism fitted. Now there are two levers. This one for the top and reverse gear fork. These are the two forks. And the second fork is for the first and second gear fork. This is a gear lever rod. Inside there is a tongue on the gear lever. It is fixed onto this thing, like a tongue. It is fitted onto the gear lever rod. Gear lever rod is mounted on the steering column, as I said. A tongue fixed on the gear lever rod, which can be engaged to either of the forks by axial movement of the rod. This tongue can be shifted here to this fork or to this fork by the help of the lever, by the rod. This selects the fork to be operated, as I said. If you slide it this side, this fork will be selected. Slide it towards this side, this fork will be selected. The angular movements of the gear shift lever slides that fork in the gearbox and thereby the concerned gear to engage the selected gear. Now this type, I don't know your generation, but I have driven this car. It was in the earlier Premier Padmini and Ambassador cars. Steering wheel, this side there used to be the gear lever on the column. So you should see these positions. This is neutral. Neutral to neutral moves the tongue from this side to this side. Let us see first. For first, move it here and then move it upwards. Here, as a result, this will get connected to the first gear. Again, bring it to neutral for the second. Same fork. Bring it to neutral and then press it down. Second gear. For third and reverse, neutral, push it back. The tongue comes here, engages this fork. For the third, upwards, it gets connected to the third gear. And for reverse, back to neutral and downward, it connects to the reverse gear. The second type is mechanism with the gear lever on top of the transmission case, on top of this one. Let's read it, then we'll explain. The gear lever ball mounted to allow all-round movement. Gear lever ball when you, if you have all any, or most of you must have driven a car, when you sit in the neutral, you can see that there is a slight play. That's nothing but it is deliberately allowed, the all-round movement. This is that. This is the knob which you hold to change the gear. In this, this is the casing of the gearbox. This is a cover to prevent dust and all that from coming inside. This is a rod which is mounted inside the casing. There will be a number of them depending upon the number of gears you have. This is the selector sleeve. This is the selector sleeve, and this is the selector fork, like this. Selector fork. Move. Selector rod. There are many selector rods inside the gearbox depending upon the number of gears. So, the lower end fits into a slot in selector sleeve. The lower end fits, there's a slot here. The slot here. So that it comes to the right position. Slight. There is a slot, means it's slight depression where this ball comes and fits, and it is spring loaded. So to move it, you have to apply slight pressure. Forks mounted on sleeves on separate selector rods supported in the gearbox casing. There must be bearings here, there will be bearings, and there will be a number of selector rods inside the gearbox casing. To avoid unwanted engagement of gear, slots made in selector rods and sleeves provided with spring-loaded balls. So some force required to overcome resistance. So, very simple. When you want to, you hold the gear knob, move it left to right, and select the selector fork, selects the required place and engages the gear. The propeller shaft. This is the propeller shaft. Propeller shaft, if you have on the GT road or any big road, if you have crossed in your motorcycle or car and seen on the side, from the side, there is a long shaft at an angle which is rotating. That is the propeller shaft, which is giving the drive from the engine to the rear differential. This is the transmission shaft coming from the engine, propeller shaft, and then of course the flywheel and gearbox, and after the gearbox, this is the gearbox output shaft, I would say. This is connected to universal joints. I'll explain to you the function of the universal joints. This is a sliding joint, meaning the propeller shaft can move in this, it's splined from inside to when the length, the distance between the differential and this reduces or increases. When will that happen? When, let's say, the vehicle goes over always as I said, it's like this, goes over a speed breaker, this will rise and the distance will reduce so that this will go in. When it comes to a depression or a gadda, this will go down relatively and this length will increase. This distance will increase. The propeller shaft on one end is connected through the universal joint to the output shaft of the gearbox, and the other end again through a universal joint to the differential pinion shaft. This is the entry into the rear differential. It is called the pinion shaft. Inside the pinion is mounted, it revolves on a big crown wheel, which is the final drive. We will coming to that later on as we cross. What is the function of the final drive? It reduces, gives a reduction, and at this stage, sufficient to know that these 1, 2, 3 shafts, and this is the propeller shaft is in between. The functions and requirements. The propeller shaft, or it's also called the drive shaft, is a driving shaft that connects the transmission to the differential. Consists of 3 parts. The shaft, this is a bigger view. The shaft, this is the shaft. Tubular cross section, its cross section is generally tubular to withstand torsional loads. We know that tubular shafts can withstand torsional because it is rotating at high speeds, low speeds, various speeds, and torsional vibrations can set in. So to offset that, we have a tubular type. Balanced, and then it should be balanced to avoid whirling at high speeds. If it's not balanced, it will whirl. Whirl means like this, which will cause vibrations and unnecessary forces which we don't want to develop. It is made of steel, aluminium, or any composite material. Propeller shaft. Universal joints. Universal joints, this is cross section of a universal joint. 1 or 2 depending on the type of rear axle drive. 1 or 2 means in the case final drive, in the drive differential drives, there are basically 2 types. One is the Hotchkiss drive and the other is the torque tube drive. We will be studying that ahead. In the Hotchkiss drive, there are 2 universal joints. In the torque tube drive, there is 1 universal joint. So, let us see the construction. This is the cross. Bearing cups, there are retaining ring. This is also retaining rings. There are bearings here so that it can rotate without noise, and also to increase the life, seal flat plastic washer. Slip or flexible ring joint. This we'll see ahead. I'll explain more of this on the next page. So as I said, universal joint, let's read more about it. Universal joint, used where 2 shafts are connected at an angle. This is the output, let's say, shaft of the gearbox. This is the propeller shaft. They have to be connected at an angle. They are connected at an angle because the differential is at a lower level than the gearbox. This is the differential, the rear differential, that big gola which you see behind trucks. So they're at an angle. Connection at each end I have already explained. One is one side of the propeller universal joint is connected to the transmission shaft, this one, and to the propeller shaft, the other one to the propeller shaft and the differential pinion shaft. Thus, connection between the three shafts, transmission, propeller and differential pinion shaft, are flexible and at angle to each other, as I explained. So, the universal joints permit torque transmission not only at an angle, but also when the angle is changing constantly. Angle is changing constantly. The road is not perfectly smooth. Speed breakers, depressions, quality of road, small gaddas, big gaddas. So, the angle is changing constantly, and this helps to keep the torque even at an angle it provided. Let's see how. Construction, when you see the construction, you'll come to know. Universal, there are two Y-shaped yokes. One on the driving and one on the driven shaft. This is one yoke, this is the other yoke. This is the other yoke. Let's say like this. This is one shaft with yoke, Y-shaped yoke. This is the other shaft, other Y-shaped yoke. In between this, there is this thing called spider. 4 arms of the spider, 2, 3, 4. 4 arms of the spiders are called trunnions. These are trunnions. Bearings in the yokes, which I mentioned earlier also, permit them to swing around on the trunnions while revolving. They swing around on the trunnions while revolving. Propeller shaft is really fast, and it allows it. Here's another type of hook joint. This is it. This is a cross piece in between. Name is given hooks joint, who invented it. This is the hooks joint. It's basically the same thing, different in construction. It's like this is the Y which I mentioned, and this is the other Y. This is the driving shaft, this is the driven shaft. And this is the spider, trunnions, 1, 2, 3, 4 trunnions, and bearings. Slip or flexible ring joint. This serves to adjust the length of propeller shaft when demanded by the rear axle movement. Sliding joint, as I mentioned earlier, the drive is like this. Sometimes the differential rear wheels, they will go over a speed breaker, go up, this will move in. So that allowance for axial movement has to be provided on the propeller shaft. Constant velocity joint. Constant velocity joint is nothing but 2 universal joints. Let's see. Use of 2 universal joints to obtain constant velocity. There are 3 shafts. This is one with the yoke. This is the universal joint. This is the second universal joint. So, this angle is the same. This is being done by these universal joints. So, the speed at which the transmission shaft, that is the gear shaft, is this thing. Let's say this is the propeller shaft, and this is the shaft going into the differential. This angle is the same. This is theta, angle same. If this is rotating at a certain speed, this will also rotate at the same speed and also at the same angle. To achieve uniform driven shaft speed, 2 universal joints used. This is called constant velocity joint. It's providing constant velocity. The intermediate shaft so arranged, this one, to make equal angle with first and third shaft. Angle, same angle has to be made, first and third shaft. The variation of caused by one is cancelled by the other, naturally. Then we come to the rubber bushed flexible joint. Rubber element between two sliding tubes. Let's say this is a propeller shaft, and propeller shaft with rubber elements inside. There is a rubber, there are two concentric tubes with a rubber element inside. I think you must have guessed for what reason it is. For smooth and noiseless movement. So that there is no clanking and unnecessary big sounds, friction and all that is avoided. This is doing the same job as this. Used in the propeller shaft with solid tube. Solid tube, and it is used in there. So this finishes the lecture. Next we will go to the various drives and progress as per the syllabus in Unit 2. Thank you.